I am K. Narsimurthy, working as an assistant professor in the Government First Aid Women's College, Tumkur. I am going to explain one of the experiment which is kept for the second semester BSc students, and that is verification of maximum power transfer theorem. This is one of the network theorem. I will go to the statement of maximum power transfer theorem. It states that maximum power is transferred across the load resistance only when the load resistance is equal to internal resistance of the circuit. If I consider a very simple circuit with one battery and an internal resistance which is R and a load resistance RL, the maximum power is delivered across this load resistance RL only when this load resistance RL is equal to the internal resistance R. That means RL is equal to R, then only the maximum power is delivered across the load resistance. Right. With this simple circuit, I am going to explain the verification of superposition theorem. So we have a battery. This battery is connected to one of the internal resistance of the circuit, and the value of this is 500 ohm. And with this resistor, I am connected to a variable resistance box, and this is the variable resistance box. From this variable resistance box, I am connecting it to a negative of the battery. It's a very simple series circuit with a two resistor, one variable resistor, one fixed resistor, that is of internal resistor of value 500 ohm, and a battery. Now, after making the circuit connection, I will keep the battery voltage as 6 volts. The battery voltage is kept as 6 volts. So with this voltage, I am unplugging the resistance of 100 ohm. 100 ohm load resistance, I am measuring the voltage across the load resistance with the multimeter. The positive of the multimeter knob should be kept at this terminal, because this is the terminal which has came from the positive of the battery, and this is the terminal which we are connected from the negative of the battery. So negative should be kept here and positive should be kept here. With this multimeter, I am measuring the voltage across the load resistance, and this voltage, it is coming out to be 1.04 volt, which is showing in the multimeter in the DC mode. So here multimeter should be kept at the voltage measurement, and it should be kept for the measurement of DC voltage. Now this voltage, it is showing as 1.10 volt. That voltage, I am recording it here in the tabular column. It is 1.01. So this is the voltage for 100 ohm resistance. Now this is the first trial. For the second trial, I am varying the resistance of the load. Load resistance is now kept for the 200 volts. I am unplugging the 200 ohm resistance. Okay. For this 200 ohm, I am measuring the voltage across the load resistance. Now I am getting the voltage as 1.85. It is varied. Now 1.85 is the DC voltage across the load resistance for the load resistance value 200 ohm. Now it is 1.85. Similarly, we have to keep on varying the value of the load resistance by unplugging the load resistance in step of 300 ohm, 400 ohm, 500 ohm, 600 ohm, 700 ohm, 800 ohm, 900 ohm and 1000 ohm. For all these values of resistance, we have to measure the DC voltage. DC voltage has to be measured across the load resistance for all these set of load resistance value. After measuring the load resistance, after measuring the voltage across the load resistance, next step is to calculate the current across this load resistance. Current can be calculated by simple Ohm's law formula, voltage divided by resistance. So current in each case has to be calculated and recorded in the tabular column. After calculating the current, next step is to calculate the power. So there are many formulas for power. I am suggesting you one of the formula for the power, and the formula for the power is P is equal to IL square into RL. So with this formula, IL is already calculated with this fourth column. With knowing the value of IL, power is calculated and has to be recorded in the last column. So after calculating the power, so we have to plot the graph of power versus load resistance. So power versus load resistance has to be plotted in the graph sheet, because power is known for all the variable resistance right from 100 ohm to 1000 ohm. For all these resistances, for different powers, we have to plot a graph. Okay, by taking power along y-axis and load resistance along x-axis. So this graph will exactly looks like this. With increase in the load resistance, the power delivered across load resistance increases in the beginning and attains the maximum value, and after that the power decreases with increase in the load resistance. This is the nature of the graph which we are getting when you plot a graph of power versus load resistance. After plotting the power, we should note down the peak value, peak point. For this peak point, draw a vertical line, and the resistance corresponding to this is RL, and that RL is equal to R. The resistance, the internal resistance of the circuit. So the power maximum at exactly power maximum, the resistance of the load will be equal to the internal resistance of the circuit, and this verifies the maximum power transfer theorem. Along with that, we can also calculate the maximum power by knowing the formula. We have a maximum power formula, P max is equal to V square by 4RL. With this formula, V square will substitute V square as the voltage of the battery, this V, and the 4RL. RL is the resistance for which the power is maximum. So RL is, you have to substitute RL as 500 ohms, which is equal to R. So this RL you substitute here, and the voltage is the voltage of the battery. If you substitute these two, you will get the value of maximum power. You are getting only one value of maximum power because you are substituting RL, which is equal to R, and that is equal to 500 ohm. So we can calculate the maximum power. We can verify this maximum power transfer theorem by showing this in the graph. These are the two things we'll do, and this verifies the maximum power transfer theorem.